welcome to today's class. In today's video, we will be looking at WAEC past questions in chemistry on the topic periodic table, ranging from the year 2004 to 2020. We have from the year 2007 question 32. In which of the following atoms is the ionic radius larger than the atomic radius? So we have option A, we have aluminium, option B, we have chlorine, option C, we have magnesium, and option D, we have sodium. The ionic radius refers to the size of an atom's ion. An atom can become an ion by either gaining or losing electrons. When an atom loses an electron, it becomes a positive ion or cation, and its radius typically becomes smaller. On the other hand, when an atom gains an electron, it becomes a negative ion or an anion, and its radius usually becomes larger. This is because the added electrons increases the electron-electron repulsion in the electron cloud, causing it to expand. In this question, we are looking for an atom whose ionic radius is larger than its atomic radius. That means we are looking for an atom that tends to gain electron and become an anion. Among the given options, sodium, magnesium, and aluminium, all these metals tend to lose electrons to become cation. But chlorine, however, is a non-metal and tends to gain an electron to become an anion. This extra electron increases electron-electron repulsion, causing the electron cloud to expand and thus increasing the ionic radius. So, the correct answer is option B, which is chlorine. Another question from the same year, question 33. A transition metal would be expected to A. Form oxide with different formula, B. Have strong oxidizing ability, C. Have low density, and D. Have an atomic structure with an incomplete outer shell. The question is asking about the characteristics of transition metals. Transition metals are elements found in the middle of the periodic table, and they have a unique property. The question presents 4 options, and we are to choose the correct one. Option A states that the transition metals can form oxide with different formula. This is the correct answer. Transition metals have variable oxidation states, meaning they can form compounds with different number of oxygen atoms. For example, iron can form iron 2, iron 3, and iron 4, which makes option A the correct answer. Another question from the same year again, 2007, question 34. Which of the following properties of atoms generally increases down a group in the periodic table? A, we have electron affinity, B, we have electronegativity, C, we have ionic radius, and D, we have ionization energy. Let's discuss this question. It's about understanding the trends or patterns in the periodic table. The periodic table is arranged in such a way that elements with similar properties are grouped together in vertical columns, known as groups. As you move down a group in the periodic table, certain properties of the elements change in a predictable way. Firstly, electron affinity is the energy change that occurs when an electron is added to a neutral atom. Electronegativity is the ability of an atom in a chemical compound to attract electrons. Ionization energy is the energy required to remove an electron from a gaseous atom or ion. These 3 properties, that is electron affinity, electronegativity, and ionization energy, tends to decrease as you move down a group in the periodic table. This is because as you move down a group, the number of energy levels, that is the shell, increases, and the outer electrons are further away from the nucleus. So the attractions between the nucleus and these electrons decrease. Hence, it becomes easier to add or remove electrons, and the atoms are less able to attract electrons. On the other hand, ionic radius, which is option C, generally increases down a group. This is because each row down the periodic table adds a new electron shell to the atoms. Thus, the outermost electrons are farther from the nucleus, which results in a larger ionic radius. So now, to summarize this, as you go down a group in the periodic table, elements tend to have a longer ionic radius but lower electron affinity, electronegativity, and ionization energy.